Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the data commands. The data commands in PowerBasic and BASIC in general date back a long way. As the name suggests, the data command is used for storing data within the application itself. This data is compiled into the application at compile time. This, of course, can be either an advantage or a disadvantage, depending how you look at it. As the data is embedded within the application, should that data require to be changed, then you will need to amend your application and recompile. This isn't necessarily a problem if you're using the data commands to store data that is changed very infrequently. Most modern applications store their data in databases outside your binary executable. But today we're going to look at the data command to store information within the application itself. So within our pb-main function, we're going to create a local variable and then call a function to populate that variable. And the name of that function is going to be buildData. The data statement is used for keeping track of string variables. If you put any numbers into your data statements, they will be stored internally as strings. However, you can convert them when you pull the information out of the data statement. So now that we've created a data statement with a list of strings, in this case eye colours, blue, green, brown, hazel, amber and grey. So these 6 pieces of data are stored within the data statement. So how can we access them? Well, first of all, we will count the number of entries in our data statement. This can be done quite easily by using the data count command. This inbuilt function will return the number of discrete pieces of data within your data statements. And now we're going to cycle through each one of these pieces of data to pull the information out. And we will be doing that by using a for next loop. We've picked up the number of data items using the data count command. And we'll go through a for next loop for long R equals 1 to the total number of entries. So within this for next loop, we're going to read from our data statement and add the information to the str data variable. And we do this using the read $command. This inbuilt function will read a particular data item from our data string. It takes a single parameter, which is the element that you wish to read. So we're reading each of the entries from 1 up until the total number of entries, which is 6. And we're adding on to the end of each of these strings a comma. As there will be a trailing comma in the string we're returning, I'm using the rtrim command to trim the rightmost comma from the string. Then we can return that data to our calling function. So having returned the data to our calling function, we can now put this out to the log to see what it has returned. So if we run the application now, it will push out to the log the string of data from the data statements. You'll notice that the quotes we had in the data statement have been removed. We're purely getting the string data, as in the name of the eye colour, and each of the names is separated by a comma. So what do we do if we need to add more data? If we go back to the buildData function, we can add another data line. This time I'm putting numbers into the data string. If we run the application now, we will see the 1, 2, 3, 4 have been added to the end of our string. The read $command will read all the data statements within the subroutine or function that it currently exists in. It will not read any data statements from any other function or subroutine. However, there is a limit of 64 kilobytes and 16,383 separate data items allowed per sub or function. There are some limitations to the data statement which you'll have to watch out for. In other parts of the code, you'll have seen me use the prefix command. The prefix command places the text immediately following it at the beginning of each subsequent line until you get to the end prefix command. This, in many cases, can save you a great deal of typing. However, the data command does not support prefix. If we tried to compile this, it would generate an error. saying data may not be used with the prefix command. Also, if you attempt to use the underline character to fold down the data to the following line, this will also not be accepted. If you wish to add more data, merely add more data statements. And you'll see for this last piece of data, we've put in here the words more test and the word data in double quotes. If we run the application now, you will see you are actually getting the data with the double quotes in it. It's treating this whole string as one element of the data. So as you will see, we can use the data statements to hold specific information in a subroutine or a function. This can be called from anywhere in your application, pulling back the data as a return from a function. However, as I have said, if you wish to change any of the data in these data statements, you will have to edit your source code, recompile the application, and release it. However, one other option, if several applications are using this key data, is to put the data into a dynamic link library. That way, should the data require to be changed, you merely have to recompile the DLL. This DLL can be dynamically loaded by multiple applications, making use of the data you have within it. So if we load up the PowerBasic Windows compiler and compile a DLL, just to perform this purpose. If we go up to the Create New File, and we'll create a DLL framework using libmain. We'll save this into the same folder as our application. And we'll call the file libdata.bas. So we're now going to create a function which will return some data in data statements. We'll call this function funReturnData. We'll give an alias of the same name, and we'll mark this to be exported as string. This will allow this function to be called from outside the DLL. And we're going to put much the same code in here as we did before. We've created a data line with the 6 iColors. I've additionally put an extra piece of text at the beginning saying DLL, just to indicate that the data is coming from a DLL. This is purely so we can see the difference on screen. We're using the read command to pull back the data from the data line, and we're using data count to work out how many entries we have in data within this function. So if we compile that, that will give us our DLL. And if we compile the DLL, it will compile cleanly. And we can see inside our folder, we now have a libdata.dll file sitting in there. So let's go back to the console compiler and we'll attempt to call this DLL function. In order to call the DLL, we'll need to declare it at the beginning of our code. We can do that using the declare function statement, followed by the name we wish to refer to the function within our application, the library name, in this case libdata.dll, and the alias, the name it is within the library. For clarity, I've kept the name of the function the same in this application as it is in the DLL, although that doesn't necessarily always have to be so. And we're declaring it to say it's returning a string. So we now make a call to this funBuildData function from within our application. If we run our application now, it will return the original data, which is the iColors followed by some numbers, and the data coming from the DLL, as we can tell because we have the string DLL at the beginning, is returning also the same iColors. So what we've achieved today is we've embedded some data within some data statements within a function within the main application. We've then used the read $command to read that data out and return to the calling function so we can display it on our console log. We've also taken the same data statements and created a function in a DLL. This allows us to keep the DLL and its data quite separate from the main application. We've then declared that DLL function and called it from our main application to display the data on the log. Data statements can be a useful way of embedding data within applications. But as with all approaches to data processing, you need to look to see how often this data is going to be updated. If it's going to be a regular update, then possibly a data command is not the place to store it. But if you have some constants that you wish to store within your application or DLLs, the data statement will work quite nicely. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.